So good morning, Ma'am Monique. I will discuss about the hydrometeorological hazard. So what is hydrometeorological hazard? Hydrometeorological hazard include tropical cyclone, also known as typhoon, and hurricanes, thunderstorm, hailstorm, tornadoes, blizzard, heavy snowfall, avalanche, coastal storm, surge, flood, including flash flood, drought, heat waves, and cold spill. Hydrometeorological condition also can be a factor in other hazards such as landslide, windline fire, locust placus epidemic in the transport and the spiral of the toxic substance in volcano eruption material. So I will show an image of hydrometeorological hazard. So what is the example of this kind of hazard? What is a typhoon? A typhoon is a mature tropical cyclone that develops between 180 Celsius and 100. In the northern hemisphere, this region is referred to as the Northwestern Pacific Basin and is the most active tropical cyclone basin on the Earth, accounting for almost one-third of the world annual tropical cyclone. I will show again the picture of typhoon. The second example is tropical cyclone. What is tropical cyclone? A tropical cyclone is a rapidly rotating storm system characterized by a low-pressure center, a close low-level atmospheric circulation, strong winds, and the spiral arrangement of the thunderstorm that produce heavy rain of squalls. And I will show again a pictures of this kind of example. The third example is a thunderstorm. What is thunderstorm? Thunderstorm, a violent, short-lived weather disturbance that is almost always associated with the lightning, thunder, dense cloud, heavy rain, or hail. And the strong, gustly wind, thunderstorm arise when the layer of warm, moist air rise in a large, swift updraft to colder region of the atmosphere. And I will show again some of the example and image of this kind of issue. The fourth example is the storm surge. What is storm surge? A storm surge, storm flood, tidal surge, or storm tide is a coastal flood of tsunami-like phenomenon of rising water commonly associated with the low-pressure weather system such as cyclones. It measured as the rise in water level above the normal tidal level and does not include waves. And I will show again some picture of this issue. The five example is the flash flood. What is flash flood? A flash flood is rapid flooding a low-lying areas, washes, river, dry lakes, and depressions. It may caused by heavy rain associated with the surf, thunderstorm, hurricane, tropical storm, or meltwater from ice or snow flowing over ice sheet or the snowfield. And I will show again some example image of this issue. The sixth example is the landslide. What is landslide? A term landslide, or less frequently landslip, refers to the several forms of mass wasting that may include a wide range of group movement, such as rockfalls. I will show some image and videos of this issue. And the seventh example is El Nino. What is El Nino? El Nino is the warm phase of the El Nino Southern Oscillation and is associated with the band of warm ocean water that develops in the central and east central equatorial Pacific, including the area of the Pacific coast of South America. I will show some example in video in this kind of issue. The eighth example is El Niño, like El Nino, but there have a difference. So let's talk about El Niño. What is El Nino all of? El Niño El Niño is a complete ocean atmospheric phenomenon that is the colder counterpart of El Nino. As a part of the broader El Nino, certain oscillation climate pattern, the name La Niña originate from the Spanish meaning the little girl by the analogy to El Nino meaning the little boy. So that's the meaning of El Nino. So I will show again some videos and image of this kind of issue.
Cyclone, typhoon, hurricane. All of these names are used around the world to describe the most powerful storm known to man. Hurricanes are unpredictable, but scientists have a thorough understanding of how hurricanes form and sustain their power. In the Atlantic Ocean, hurricane season peaks during the late summer months when tropical waters are the warmest. Hurricanes form from a cluster of thunderstorms that suck up the warm, moist air and move it high into Earth's atmosphere. The warm air is then converted into energy that powers the hurricane's circular winds. These winds spin around a low-pressure center called the eye, which can provide a 20 to 30-mile radius of eerie calm. Encircling it is the eye wall, a towering ring of clouds with some of the fastest wind speeds of the hurricane. Surrounding the eye wall are curved bands of clouds, the rain bands, often tens of miles wide, releasing sheets of rain and sometimes tornadoes. When a tropical storm's winds reach at least 74 miles per hour, it becomes a hurricane. The hurricane then receives a category ranking of 1 to 5 on the Saffir-Simpson scale, based on its wind speed and potential damage. But wind speed isn't always the most dangerous component when hurricanes come near land. It's storm surge. Storm surge is caused when winds from an approaching hurricane push water towards the shoreline up to 20 feet above sea level and can extend 100 miles. 90% of all hurricane deaths are the result of storm surge. While hurricanes can cause mass devastation, just like other natural disasters, they serve a higher purpose within the global ecosystem. Hurricanes help regulate our climate by moving heat energy from the equator to the poles, keeping the Earth's temperature stable. Over time, science has helped us to better understand hurricanes and predict their paths, saving lives through early warning systems and helping us build better infrastructure to protect our cities. The more we study these complex storms, the better we can prepare for them and minimize their impact on human lives.
A natural force of nature unlike any other, El Niño is capable of unleashing a fury of climate changes and natural disasters that span from Alaska all the way to South America and beyond. What causes El Niño, and how are we affected by it? El Niño is not a storm, but rather a weather phenomenon in the Pacific Ocean. During an El Niño, the surface water temperature warms up, leading to complex weather patterns. South American fishermen in the 19th century, describing warmer waters during Christmas time, coined the name El Niño, Spanish for the Blessed Child. Nowadays, when sea surface temperatures in the equatorial Pacific Ocean rise 0.5 degrees Celsius over their historic average for 3 consecutive months, and once atmospheric conditions and rainfall patterns shift accordingly, scientists officially declare an El Niño. An El Niño event takes place about every 2 to 7 years. Normal east to west trade winds over the Pacific weaken, and warm water that normally travels westward is now moving toward the east. Moisture then rises into the air, and the effects of El Niño are felt throughout the Americas. In the ocean, warm water pushes colder water downward, blocking the important upwelling of nutrient-rich waters from the bottom. This causes some marine life to migrate to colder waters. Animals that normally feed on this sea life suffer, and fisheries throughout Central and South America suffer too. But El Niño's most noticeable repercussions are felt on land. In the western United States and Central and South America, the warm air and moisture lead to increased storms, rainfall, floods, loss of life and property, and the increase of some vector-borne diseases like malaria, even in places where they don't normally occur. In Southeast Asia and Australia, the opposite takes place. These areas suffer from drought, wildfires, and colder ocean waters. In 1997 and 98, the world experienced the biggest El Niño in recorded history. Some estimates blame that El Niño for 2,100 deaths and $33 billion in damages. Mongolia saw temperatures reach 108 degrees Fahrenheit. There was record flooding in Peru. And the U.S. saw storms in the Gulf Coast, flash flooding from California to Mississippi, and tornadoes in Florida. Scientists are now better able to predict if and when an El Niño event will take place. This helps communities better prepare for the changes in weather patterns and better adapt to its.
So that's all the example of hydrometeorological hazard. Thank you, Ma'am Monique, and God bless. Thank you.